Hi, Timothy Unkert here. In this video, what I'm going to do is I'm going to create a program. Let's save this program as is_prime.py. Now, yesterday I did a video on finding prime numbers in C up to a target amount that the user enters. I'm going to do that again, except with Python this time, and I'm going to improve the looping a little bit, okay, and maybe take a look mathematically at the looping and see what kind of time complexity we're getting. Okay, so let's get started. So the first thing I want to do is get a target value from the user and just check for errors when they enter in that target value. So I'm going to say while true, okay, and then I'm going to try to get a high value as an integer, okay? So I'm going to do a try, except else here. And what I'm going to say is we're going to try is to get a variable high value, which is going to be an integer input. And we'll say what is the highest integer you want to check up to, okay? So that's what I'm going to try, and we'll put a space there. Get out of that. I'm going to get rid of this. Oh, no, not that. And what I'm going to do here is, if they enter in something incorrect, I'm going to print something to say, listen, buddy, I said enter a positive integer. And actually, what I should do is say what is the highest positive integer? So I should actually tell them that. So I'll say that here. What is the highest positive integer? Okay. Now for this else, what I'm going to say is if the high value is greater than 0, well, all we're going to do is we're just going to break out of the loop. Okay. But else, if it's less than 0, I'm going to print the same thing. I'm going to print, listen, buddy, I said enter a positive integer, okay? So we're doing some little checking there, make sure they enter a positive integer. Okay, we've got that. The next thing, what I want to do is I want to create an empty array to hold the prime numbers. So let's make a comment here. We're going to create an empty array to hold primes, okay? And we're going to say the primes underscore ARR for array is just going to be an empty array, okay? All right, so after that, I want to create a Boolean, and this Boolean is going to basically, for checking for a prime number. So we're going to create a Boolean to check for a prime number, and I'm going to initialize it to true. So what I'm going to say is underscore prime equals true, okay? And now I'm going to create a for loop, and we're going to have a nested loop to find the primes, but I'm going to make it a little bit different so we don't go a full for loop both times, and we can talk about this in a moment, but let's make a comment here that we're creating or create for loops to find primes, okay? So what I'm going to say is for number in range 2 to the high value plus 1, okay? What I'm going to do is I'm going to do another loop, and I'm going to say for other underscore number in range, and we're going to go from 2 to the number and then stop, okay? And we'll talk about that in a moment. All right, so next what I'm going to look for, or I'm going to create, is an if statement. So I'm going to say if number modulo other number, if that double equals 0, so if that's equal to 0 and the number is not equal to the other number, well, then it's not a prime number. So what we're going to do is we're going to, let's make a comment. If this happens, set Boolean to false because this number is not prime. And we'll do that. So we'll say is prime equals false. We also want to break out of the loop. So we're just going to have a break here, okay? But otherwise, we'll say is prime equals true, okay? And we'll go outside the loop here. And now what we want to do is we want to check if is prime is true. And if so, we'll append a number to the primes array, okay? So we'll just say if is prime double equals true, okay? What we're going to do is we're going to take this primes array and append the number, okay? All right, so we'll go outside of that loop, and then we're going to loop through the numbers and print them out. So let's loop through the numbers in the primes array and print them, okay? So we'll say for value in primes array, what we're going to do is check if the value does not equal the primes array, the last term. And the way we do that is do the primes array, and then in brackets we have a -1. So if it's not the last term, and I'm going to do this just for formatting's sake, what we're going to do is we're going to print the value, but we're going to have the end here equal to just a comma and a space, okay? The only other option is that it is the last value, and then we'll just print the value. And that's going to format it nice for us, okay? So let's open this up, and I've got this small again. I should keep this on 20. I'll put my size up to 20 here. And I'm going to cd into, this is in YouTube, and we're going to run it. Python 3 is prime.py. Let's run it. What is the highest integer you want to check up to? Let's say 40. So it lists all the numbers that are prime up to 40. Just like we did with the program in C yesterday. Okay, so I'm going to bring up a browser here for a moment, and let's go to Draw Island and take a look at that. Okay. And let's make this a bigger one. And what I want to think about is this looping here, because in the second one, I went all the way up to the high value both times. So it's definitely O of n squared. This time, I'm only going up to the number, okay? And let's go through like 10. We'll start at 2 and go to 10. So we'll do 2, 3, so on and so forth. Just go up to 10, all right? Okay, and so the first loop is going up to our high value plus 1, okay? Well, actually, no, sorry. It's just going up to the high value. And this one is going up to right before the number, okay? So, it's going up every number up to the number, because obviously the number is going to be divisible by itself. And so this is a check. We probably don't need this, right? We can probably eliminate this part because it's not going to equal the other number, right? Except if we start at 2, yeah, it might. So, but we probably could work our way around that. But anyway, so that's a code review I'm giving myself. Think about that, Tim. Okay, I thought of a different way of explaining this. So when we're looping through in this loop here, we're only going up to the number that's here. Okay, so we're not doing, like if we go from 2 to 11, that's 10 items, right? And then, if we did 2 to 11 here, that would be 10 times 10. So that would be a loop of 100. Okay, so that would be n squared would be 100. Now, 100 iterations with both loops nested. Now, if we go up here, when we think about it, when we go to the first number 2, we only go to 2 here. So we've only got 2 iterations. When we go up to 3, we add an iteration through the loop, but then we only go 2 and 3 here, so we add only 3. Okay? When we go up to 4, we add an iteration through this top loop, and then we go 2, 3, 4, so we add 3 more. So we add 1 plus 3 is 4, and we keep going. We keep adding an extra 1 each time we increase the number. So here's the 10 numbers. So we got 2 plus 3 is 5. 5 plus 5 is 10, 14, 20, 27, 35, 44, 54, and 64. All right, so we have 64 iterations. The way this loop is set up, we've cut it down from an n squared of 100 iterations, which is what I did with the C program the other day. I don't know why I'm going to save this. It's just for demonstration purposes. So let's pull out Desmos and let's take a look at this curve. So we'll go to Desmos Graphing here. And let's just graph this. And what we'll do is we'll graph a few things. Y equals x squared. We'll look at that graph. And let's go out a little bit. Okay, so at 10, we're jumping way up, right? And also, let's graph a couple other ones. So let's graph y equals x log x, that, and then y equals x, graph that, y equals log x. Okay, so here's some different big O trajectories. So, log n is really good. N is good. N log n is okay. N squared, not so good. All right, so let's think of where we are if we're going up to, let's say, 10 here, all right? And we can extend this. Let's even go up to 20, right? So if we do 20 with n squared, we get a point at 2400. Okay, so that's going to be way up here on this curve, okay? If we keep going here, so this first part was 64, and then we just, let me just put a pipe here so I know. So we do 12, 13, 14, 15, 16, 17, 18, 19, 20, and then 21, right? So if we add all these, let's just go here and just add that. Go here, and we got 165, and we're going to add the 64. So we're only at 229 here, so we're definitely better than 400. So at, this is at n equals 10, right? And then, we'd have 400 iterations at n equals 20, but we're at 229. Okay, so we're still lower than that. So let's see if we can see this on Desmos a little bit. Like really scale out. We've got the 1 here. So we'll do a couple other points. We'll do 20 to 29. Okay, that's a little bit better. It's still way closer to this than the other one, unfortunately. If I keep going out, to 31, let's just put a pipe here. Do 31, 32, whoops, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41. Okay, that's another 10. So that's going to be 900 iterations when n equals 30. But let's take this, we'll copy it, and we'll just add this to 229. So we'll say, Just 229 plus all of this, we get 625. Okay, so that's still, it's getting better, but it's not quite where we want it to be. But let's try that. So we do 3,900, plot those. And then what do we do? The other one's 30. And what did I say? 625? 625. Oops. And let's actually put these as an ordered pair. Okay. And if we keep zooming, so we've got the blue here. The green is falling below it, but still not quite here. So it's a little bit better. 625 over 30 iterations versus 900. If we took this to a much larger scale, it would still be a somewhat of improvement, but it's not quite getting close to the n log n where we want it to be. Anyways, I thought this might be an interesting look at it. I wasn't even really sure when I started this video how much better that would be, but it is a bit better at larger inputs. If we continue, I'll just one more. If we do 40 or if we do n equals 40, we have with the C program that I wrote yesterday, I'll link that. It's 1,600 iterations, and then so I would add 625, and then I would add it to this. So let's do 42 plus 43 plus 44 plus 45 plus 46 plus 47 plus 48 plus 49 plus 50 plus 51. Okay, and we'll go back here. Copy all that, and let's just do a new tab here. We'll do 625 plus all of that, and nope, not plus plus. I just want plus. What does that equal? Okay, 1090. Okay, so we're dropping off just at 40 iterations. We're dropping off already over five. Just at input of 40, we're dropping off 510 iterations. So we are making some kind of gain in terms of the time complexity. It's not quite where I want it still, but it is better. Anyways, if you think you can make it even better, comment in the comments below. I'm sure you can. Anyways, that's it. If you like this video, please give it a like. Otherwise, don't. Also, if you want to subscribe, subscribe as it really does help the channel grow. Thanks for watching, and I hope to see you in the next one.